Well, hey there kiddos, and welcome to your video over multiplying polynomials. So we're going to start with algebra tiles, and so there are a few things you need to know first. We're going to use these algebra tiles because it helps you to see what we're doing as an area model, as the area of a shape, so that you can see how everything fits. Plus, when we go to working backwards from this to doing something called factoring, this area model comes in very handy when you're trying to go backwards. So if you can make the area model, it makes your life so much easier, and it sort of helps make the connection between what it is that we are actually doing. So things that you need to know first about algebra tiles: the big squares here are x squareds, and so the yellow one will be x squared, the red one will be a negative x squared, and then the long rectangles are our x's. So again, yellow is x and red is negative x, and then the little squares are our units, and so yellow is positive and the red is our -1. And so you have this on your paper, you have a place where we can do this algebraically. So here is how this works. We are going to end up multiplying. Make this so you can see the whole screen. And so what we have to do is we're going to end up doing x plus 1 times x minus 3, which means we're going to end up, one side of our rectangle is going to be x plus 1, and the other side of our rectangle is going to be, x minus 3, so it's going to have 3 negatives. And so when we multiply these together, this is going to fill in and create a rectangle that matches the area for these two sides as our dimensions. And so we're going to do two at a time. So we're going to do x times x, and if you do x times x, it makes x squared. And then when I do x times -1, it makes a negative x, and I'm going to put them side by side so they're touching, but you don't have to. You can leave a little space. And then x times -1 again makes another negative x. And then again, x times -1 one more time makes another negative x. So what I have done is I've done this x times this x, which made x squared. And then I've done this x times -3, which made -3x, because I have 3 negative x's. So now I'm going to multiply this 1 right here times both of these. So I'm going to do 1 times x, which makes an x. So I'm going to line it up down here. And then when I do 1 times -1, it makes -1. And then again times -1. And then again times -1. So I've created this area model. And so what I have is x squared minus 3x plus x minus 3. So I've done this x times both of these, and I have done this 1 times both of these, and it's filled in and made an area model. Now this x and this x together cancel one another out because, wow, my brain just stopped working. You have a negative x and a positive x, they cancel one another out, and so they make a 0 pair. So this x and this x cancel each other out. And so now I have a weird, wonky looking area model, but that's because I have taken out the 0 pairs. But what I have left as the answer to my problem is I have 1x squared plus, sorry, that's not plus, 1x squared minus 2x minus 3 is what becomes my final answer there. And so I'm missing parts of my rectangle because they made 0 pairs and canceled, but this is what I have remaining, and so that's what I end up with when I multiply. So let's try another one. So I have x plus 1. So right here, the dimension here is going to be x plus 1. And then up here I'm going to have x plus 2. So I have my x plus 2. And so everything's nice and positive. And so when I multiply, here's what's going to happen. I'm going to do x times x, which makes my x squared. Then x times 1 makes 1x. X times 1 again makes another 1x. And then, so I've taken care of this x times both of these. Now I've got to do the 1 times both. So 1 times x makes x. And then 1 times 1 makes 1. And times 1 again makes another 1. And so you see I've made this nice pretty rectangle. It's all yellow, so nothing is going to cancel each other out. And so what I have as my final answer is I have 1x squared plus 1, 2, 3 x's plus 2. So that's what we're doing. So it makes this nice little area model, and you're not always going to see the area model because we're not always going to write it this way, but this way you can see that I'm multiplying a length times a width to get a rectangle, and what I get as my answer is the area of that rectangle. So now we're going to do the product of two polynomials, and I'm going to show you two different ways to do these problems. Once you get to where you're solving these on your own, you can pick whichever method you like best. So I'm going to alternate between the two so you can see them both happening, and then you can pick the one you like the best. So the first one that we're going to use I call double distributive property, which is just the distributive property twice. So I like to double distribute. And so here's how it works. When I double distribute, I take this x times this x, which makes x squared. And then I distribute this x to this negative 5, which makes negative 5x. So I've distributed once. I've distributed this x to both of these. Now I'm going to distribute this negative 3 to both. So I'm going to do negative 3 times x, which makes negative 3x. And then I'm going to do negative 3 times negative 5, which makes plus 15. When I do that, you'll see that these two terms in the middle are both x's, so I can combine them. So I can rewrite this as x squared minus, now negative 5 minus 3 makes negative 8x plus 15. So this right here would be the area of the rectangle that has this as a length and this as a width. So here is your answer. Now, if double distribution is not your thing and you don't like it and you're a more visual kiddo, that's all right. So here's what we will do, and this goes right along with the algebra tiles that we just did, because these make what I'm about to do perfectly. They turn into a box like I am about to do on my paper. So they make a box like this. So we're going to create a box. And if you have done genetics and biology, you've seen something similar because it looks like a Punnett square. It's very much the same. And so here's my length. So I have 3x minus 2. And then here's my width. I have x plus 4. And I'm just going to multiply one little box together at a time. So I'm going to do 3x times x, and that makes 3x squared for this box. Then I'm going to do 3x times 4, which makes 12x for this box. Then negative 2 times x, which makes negative 2x here. And then negative 2 times 4, which makes negative 8. And when you do the box method, you should see that these two boxes on the diagonal right here match together. That's because they should always end up the same, and so I can combine them. So I'm going to start at the top right corner, and I'm going to write 3x squared. Sorry, top left corner. I'm going to combine my x's, so 12x minus 2x makes 10x. And then my bottom right corner minus 8. So this is the area of the rectangle formed by these two dimensions. So let's do number 3. Again, I'm going to do number 3 using the double distributive property so you can see that happen again. And then with number 4, I'll use the box method. So 2 minus y, the whole thing squared, actually means I have to do 2 minus y times 2 minus y. Because to square something means to multiply it times itself. If you do not take this kind of problem and write it out, expand it, this thing times itself, you're going to struggle with these kinds of problems because you're going to miss a term in your answer and you're going to get it wrong and you're going to be like, I don't understand. And so you have to write it out. You have to understand this means this thing times itself, and you need to rewrite it. So double distribute. 2 times 2 makes 4. 2 times negative y makes negative 2y. Negative y times 2 makes negative 2y. And negative y times negative y makes positive y squared. Now these two terms I can put together, so I have 4 minus 4y, it's negative 2 minus 2, plus y squared. There is your solution to that one. Now number 4, I'm going to use the box method again, but if you'll notice, this is a binomial times a trinomial because this has 2 terms and this has 3. So when I make my box, it needs to be 2 units one direction and 3 units the other. So it's got to be a 2 by 3 box. So we're going to draw a rectangle, and I'm going to cut it in half this way, and then I'm going to cut it into 3 parts this way. I hope y'all draw straighter lines than I do. So my 2 goes here, so I have 3x minus 5. Then across here I have 2x squared, 4x minus 3. So we're going to go one box at a time and multiply. So 3x times 2x squared. The 3 times 2 makes 6. And then when I multiply x and x squared, I add the exponents together. So this becomes x to the third. Then when I do 3x times 4x, 3 times 4 is 12, and the x times x makes x squared. And then 3x times negative 3 makes negative 9x. Now for the bottom row, negative 5 times 2x squared makes negative 10x squared. Negative 5 times 4x makes negative 20x. And negative 5 times negative 3 makes positive 15. Now if you'll notice, my diagonals again are matchy-matchy, so I can put them together. So start with top left corner, 6x to the third. Then 12x squared minus 10x squared makes plus 2x squared. Negative 9x plus negative 20x makes minus 29x. And then plus 15. So now you have a polynomial that has 4 terms instead of just 3. That happened because of the size of the stuff I was multiplying together. But there's your box method. You just make it as big or as small as you need to for what you're multiplying, or you can double distribute. Both methods work. I don't care which one you choose to use. The box method comes in really handy when we start to factor because it makes a nice visual for when we go backwards. But if you just hate it, don't do it. Double distribute it, it's fine with me. So we'll practice this when you guys come to class tomorrow. I'll see you then.